In this video, we are going to prove Holder's inequality for sums. So to get started, we're going to define the following quantities. So we're going to define xi for each I to be ai divided by sum j equals 1 to k, aj to the p to the 1 over p. And then we're going to define yi for each I to be bi divided by sum over j equals 1 to k, bj to the q to the 1 over q. Okay, and we want to notice that if all of the aj's are identically equal to 0, or if all of the bj's are identically 0, then these expressions are not defined. So from this point on, we're just going to assume that that's not true. And if all of the aj's or the bj's are identically equal to 0, then this inequality automatically holds. So we can assume that that's not the case. So the reason that these values are useful to define is that now we can apply Young's inequality, which tells us that for each I, we have xi times yi. This is less than or equal to xi to the p over p plus yi to the q over q. Okay, and this works because p and q are Holder conjugates of each other, and also because xi and yi are non-negative for each choice of I. Great. So another way to write this is ai bi divided by sum aj to the p to the 1 over p, sum bj to the q to the 1 over q, that this is less than or equal to 1 over p ai to the p, and then just this sum. So just the sum of aj to the p, because we raise to the p power. And then plus 1 over q bi to the q divided by sum bj to the q. Great. Now we can take this inequality and we can sum it over all values of I from 1 to k. And what that gives us is sum over I equals 1 to k ai bi divided by sum aj to the p to the 1 over p, sum bj to the q to the 1 over q, and these are j varies from 1 to k, j varies from 1 to k. And now this is less than or equal to, and notice that if we sum this expression right here over all possible choices of I, we just get 1, because the thing on the top cancels with the sum on the bottom. And then likewise for this expression. And so this is just 1 over p plus 1 over q. Okay, but p is the Holder conjugate of q, so 1 over p plus 1 over q is equal to 1. And now if we multiply both sides of this expression by the sums on the bottom, then we get the desired inequality. And that's it.